Machine learning, data science, artificial intelligence. What exactly are they? You'd have probably come across these terms at least once in your life, and you're watching this video maybe because you are a beginner in this field, or you are genuinely interested or passionate about this field of machine learning and you just want to know more, or you're planning to switch careers. Whatever may it be, you're at the right place, because in this video we're just giving an introduction to what machine learning is. Let me introduce myself. I'm Alistair Louise, and this is the first time I'm actually showing my face on camera. I finally got the courage to show myself to you guys. Previously I was behind my computer screen and I had this mic, and I was just doing weekly newsletters and machine learning tutorials. I plan to continue with the same exact format, maybe a little less of weekly newsletters and more of tutorials. And I also have a plan of having 3 machine learning playlists. So I will be basically having a beginner series, an intermediate series, and an advanced series. And this is episode 1 of the beginner series, so you're at the right place. This is where you get started. My goal is to take you from a complete beginner in this field to a professional in this field, a zero to hero, as they call it in Udemy. However, this is completely free of cost, and I will be putting it on YouTube. And I plan to be along with you across this journey, and I can also learn a lot from this as well. At the same time, I also want to bring you guys the latest advancements in the field of machine learning, as seen in my previous machine learning newsletters and so on. I will have a written blog summarizing today's video down in the description in my blog page, so feel free to check it out if you want a written format, and leave a like, comment, and of course subscribe, and that'll keep you motivated in completing this beginner to advanced series. Also, to keep things fair, I will not be having a beginner series video every single week. My plan is to mix it up. I might have an advanced video one week and then an intermediate video the other week. So the playlist will keep on getting updated, and if you guys have any suggestions or feedback regarding this, feel free to drop down in the comments below, and I'm more than happy to take that idea up and explain and elaborate it for you guys. So with that being said, let's get to the point of today's video about what is machine learning. So the way I think about it is using a simple analogy, which might help you guys as well. So imagine a child is learning how to ride a bicycle. Obviously, they do not have every single muscle movement pre-programmed within them, and they learn via trial and error. At least for me personally, unless you are a superhuman. So you basically start by riding a few meters. Each day you go further and further until you become proficient in riding a bicycle. Similarly, we can think of computers or machines being able to learn from data. So given the data, they learn patterns or improve upon their knowledge in every single iteration or epoch. So that's basically what machine learning is. And today, computers are powerful enough to learn from large amounts of data and build state-of-the-art models that are able to provide output values given a certain set of inputs. We live in an era where machines are able to make decisions without someone actually supervising it or being explicitly programmed. And that is the beauty of machine learning. You have heard of personalized recommendations in Netflix, or self-driving cars that are being built in different parts of the world. All of these are like machine learning applications, and they're shaping up our future and the world around us. Anyways, to help you guys further differentiate between AI, machine learning, data science, deep learning, as you can see in the Venn diagram, inside it we have machine learning. So machine learning is a subset of AI, and inside machine learning we have deep learning, which is neural networks, and neural networks are basically trying to mimic the function of your brain. And then we have data science, which is a crossover between data analytics and artificial intelligence. Basically, you're trying to solve business problems using the power of AI or machine learning models. So one way you could also think about it is your normal programming, which is rule-based learning. So you explicitly define rules and your program will follow it. Whereas machine learning is data-based learning. So you give plenty of data and the model automatically infers from the data and comes to its own conclusions. There's also learning by trial and error, which is called reinforcement learning, and that's going to be part of the advanced series maybe somewhere in the future, so stay tuned for that. So since I've already name dropped reinforcement learning, now is the right time to mention about the different types of machine learning applications. So we have mainly 4 types of machine learning applications, starting with supervised learning. We have unsupervised learning, we have reinforcement learning, and we have semi-supervised learning. Any of the machine learning applications or projects that you work on will usually come under any of these 4 different categories. So we can understand supervised learning via a simple analogy. So imagine you are a student in a classroom and a teacher give you a set of questions with their answers. So you can solve the questions knowing the answer one by one, and you will automatically come up with a set set of patterns on how you can solve each and every question. Eventually, you get better over time, and this is exactly what a machine learning model does in a supervised learning scenario. So you give it a set of data with correct labels or the correct answers in your case, and the model automatically learns or derives patterns from the data to arrive at the output. So each and every iteration, it gets better and better. Okay, so the next type of machine learning application is unsupervised learning. So again, another analogy to help you understand what unsupervised learning is. Imagine you are in a party and you meet a lot of people that you do not know, and you want to figure out if they are work friends or they are family. So depending on how they interact with each other, in your mind, you group or cluster them into work friends or family friends without knowing the actual outcome. So this is exactly what unsupervised learning is. There is no correct label. So in the previous example, imagine the teacher doesn't give you the correct answer sheet. So you do not know the correct label, so you just assume or group data together based on similarities. So that's exactly what unsupervised learning is. In this example where I gave you, you are grouping people based on if they are work friends or if they are family based on how they interact with each other. Okay, so the next type of application is reinforcement learning. So as I mentioned earlier in the video, like the self-driving cars, which are going to be a thing of the future, reinforcement learning is the backbone of self-driving cars. Similarly, any sort of robotic applications that you may come across, reinforcement learning is what powers them. So again, the best way to explain to you is via analogy. So imagine you're training a dog and you are telling the dog to sit down, and if the dog follows your command, you give it a treat, let's say a biscuit. And instead, if it doesn't follow your command, you do not give it a treat. So as time goes by, the dog automatically learns or optimizes on what actions it needs to do to get a treat from you. So in the supervised learning case, we give it a set of outputs. No, it automatically learns by itself using trial and error. So this is how reinforcement learning works. The last sort of machine learning application, which is not very widely used personally, is semi-supervised learning. So let me explain to you via another analogy. So imagine you're studying for a test and you have a textbook and you have a guide. So in the textbook and the guides, certain questions have answers to it and majority of the questions do not have answers to it. So you basically learn the answers from those questions that actually have answers to it, and then you try to answer those that do not have answers to it using your previous knowledge. You use all of the information that you gained from those questions with answers to answer those that do not have answers. So translating it to machine learning lingo, so you train a model on a small subset of labeled data and you use it to make sense of unlabeled data. So you'd be wondering why and how did machine learning grow so much over the past few years? This is because everybody has easy access to machines that can process large amounts of data and give us accurate predictions much better than a human could actually do. Since the computational capabilities of machines have increased over the past few years, so has machine learning. That's why you would probably come across an AI solution in your day-to-day life, whether may it be in a financial institution or a healthcare institution and so on. So to summarize everything that we have discussed so far, all the different machine learning applications, machine learning models learn from data. You give it data, historic data, customer sales data, whatever may it be. The model learns patterns from this data and iteratively gets better over time, giving you more accurate predictions. Much better than a human could do. Okay, so since we have discussed what machine learning is and what are the different types of machine learning applications, let's actually understand how machine learning works. We call this the machine learning pipeline. So what are the steps in this pipeline? The first important step is data collection, and this is basically common sense because we know that for any model we need tons and tons of data from which it needs to learn. So obviously the first step in the pipeline is going to be to collect this data. Once we have the data, the next step is feature extraction or feature engineering. This is basically extracting useful information from the data that you think the model will find useful. And the next step is the model training part. So you have all the useful features extracted, you feed it to the model starts training, iteratively it gets better and better. Then we have the model testing phase. So once our machine learning model is ready, we obviously test it on a testing set that the model has not seen. This will tell whether the model has actually learned accurately or if it has overfit on the data. You can think of it like the model learning too much, or given an analogy again, you by heart all the answers that the teacher gives you, and in an exam when an actual question comes which is different from what you have learned, you do not know how to answer it. So the goal of machine learning training or model training is to generalize well on unseen data. So that is why we have the model testing phase. Once we get a green signal and the model testing goes well, the last step is deploying this model on production, or obviously giving it real-time predictions. So let me explain or summarize this machine learning pipeline in form of another example. So imagine you are building a model that distinguishes whether an image is a cat or not. So first step is that you collect the images containing cat images or and any other animals, and then you label them as cat or not cat, because this is a supervised learning problem. Then you pass this data to the model, and the model learns patterns from these images, such as pointy ears, whiskers, or features that are unique to a cat. This will help the model basically distinguish between a cat or not a cat. And once again, you would need to have train and test splits, because this is a supervised learning problem. So the training data is what actually goes to the model to help it learn patterns to distinguish between a cat and not a cat. And the testing data is what you'd use to evaluate the model, whether it's actually learning correctly or generalizes well or not. This is the ultimate goal of any machine learning project. No field is without its challenges. So machine learning is nothing special. It also has challenges. One of the major challenges that we face is that the data that we train the model on could be biased. Since data, as I mentioned earlier, is the backbone for any machine learning model. If the data is biased, the model is going to be biased, and it's going to give you inaccurate predictions. Although the model will look great while training and testing, in the real world, it will be inaccurate. So this is one of the challenges. It is important that we ensure that the data that we collect is truthful and is not biased. And if we pass accurate and reliable data to the model, we are going to get accurate and reliable results. With tons of exciting updates and advanced applications happening all across the world in this field, now is the perfect time for you to go from a complete beginner to an advanced machine learning engineer capable of building your own machine learning models. And I'm excited to be with you across this journey, and I hope my playlists will be helpful for you in taking you from absolute beginner to a proficient machine learning engineer. Since this is my first time actually showing my face on camera and presenting live, I hope that I can improve upon my skills over time, just like any other machine learning model. And if you found this video useful, please leave a like and subscribe. It truly means the world to me. Please leave a comment on what you'd like to see next and any other topics you'd like for me to discuss with you guys, and I'll try my best to bring it forth for you. So thank you so much for watching. Hope you all have a great day ahead, and take care and peace.